In this video, we are going to talk about the most common problems which happen during board assembly. And I'm not an expert for board assembly, so I had a call with Amit. I recorded the call, and that's what you will see in this video. We are going to start with tombstoning. Here is my call with Amit. Many people ask me if this is really still happening or not.
Of course it's happening.
Is it?
Yeah.
Because
Y-
when I'm building, when I usually send the boards to production, they don't complain. So you just fix it quietly and you never tell customers. Okay.
Yeah, there's if you are in if you're in the industry of military or aerospace or medical and you flow the requirement to the vendor that you can't change anything without letting us know, that puts a lot of burden on the vendor and they'll charge you more, but at least as a customer you know what is getting built.
Mm-hmm.
If you're not flowing down any requirements like that to your vendor, then they're changing things and fixing things all the time,
Mm-hmm.
and they're not telling you. And that doesn't make you a better designer, and you don't know what you're making or what they're making. So this vendor agnostic approach doesn't really exist. If you take the same design from one vendor to the next vendor might have problems building the product. And it's not because they're, let's say, a bad vendor. It could be because your first vendor learned the issues, fixed the issues, didn't tell you what those were. And now the second vendor has to start over and they have to learn what are
Mm-hmm.
the issues with
So
your design.
is there some kind of way how engineers could get this feedback from the assembly house what is wrong? Shall they always like ask what they should improve or
You have to, yeah, so there's two things. First of all, if you want to get feedback, there's two things I would do. The first is I would review with your vendor before you actually manufacture. So
manufacture
don't just send the
PCB or
data,
assemble boards?
both.
Okay.
Review everything before you manufacture because you might have a chance to fix some things before manufacturing, which is good. Then after manufacturing, well, I should say in your requirements, flow down requirements to the customer, you have to say, please, you know, not please. I mean, please is good, but you have to say no changes to data are allowed unless approved by me,
Oh, okay.
approved by the designer. So then, the operator in manufacturing, whether it's fab or assembly, they'll see that note and then they won't do what they usually do. They'll have to reply or get a reply from the customer. And in which case, as a customer, you would now know what are the changes that are happening. And you can explore further. Why is that change needed? What can I do differently? Things like that. Yeah, so tombstoning happens, and tombstoning happens when there's improper, let's say, design, right? Improper pad design, improper solder paste stencil design, improper manufacturing.
And
So
what is
tombstoning,
improper? Like too much solder, or the heat is taken away sooner from one part than the other one, or
exactly. That's exactly what happens. If you let's say for example, your solder your solder mask opening um, is not appropriate for that component, right? And let's say that there's more copper underneath as I say, there's a copper pour, a copper ground that goes right underneath the components. There's all these specific things that can go wrong with that component that could cause the defect. The defect is the result. You have to analyze what in your design caused that defect. It's never one thing. So that's the root cause assessment that is specific to your design. So, for example, if you have like the heavy copper example, you know, you could have, not enough heat because you have so much copper, and then the right, let's say, profile wasn't used in assembly. But it wasn't the right profile because of your design, whereas in another design, the profile would have been fine. So it's very design specific, and that's why, um, you know, the root cause assessment is where you figure out, this is what needs to change in
Mm-hmm.
the design, or this is what needs to change in manufacturing, so that doesn't happen.
Mm-hmm. So even these tombstones can be fixed, for example, by adjusting the soldering profile, for example.
Absolutely, yes.
Okay. So there is no like one universal answer, because sometimes you can see these recommendations like never fan out PCB, the component path to the left or right, just do it straight way, for example, or never connect it directly to ground plane or something like this, because we often do it. When the PCB is very high density and there is only one place where you can put via, you can't really choose if you would like to put it left, right, or somewhere. You just have to do it. And if it was so bad, then I'm pretty sure assembly house would tell us like every second component has problems, but they never tell us that every second component has problems. So they always
Yes,
somehow find a way how to fix it anyway.
yes. So, for example, the via close to the pad or the via in the pad, um, people have been doing that forever, but the assembly houses, they'll touch up and rework and add more solder, whatever solder that's flowed, or wicked into the hole, they'll add more solder and kind of fix the problem. In production, that's really not feasible. And so that type of thing should be caught at the time of product development.
Mm-hmm.
And so when we have a universal issue like that, we do start checking for that. So, via in pad, via close to pad, those are design rules that we will analyze designs for those issues, so that the customer can make the change. And if they can't make the change, then we'll do the best we can
Mm-hmm.
for that product, for that build. But if they, at least they'll learn for next time, don't do that same thing, or that would cause a potential problem.
So what can you do? You fill up the via then somehow, or
Yes.
as you said, you add
Yeah.
more solder, or
Yeah. The right way to do it is called via fill. So
mm-hmm.
in PCB manufacturing, you fill the via with a non-conductive epoxy. We use SANA, and the non-conductive epoxy is um, it's squeegeed into the via, and then it's baked, and then you have to planarize the surface so that
Mm-hmm.
the pad is still flush and the copper is still flush. And so that's like a lot of extra PCB manufacturing steps. And the only way that a PCB fabricator knows to do that is if the designer tells them.
Mm-hmm.
And the only way the designer knows to tell them is if the assembly shop gives feedback saying, that a lot of solder wicked into that
Mm-hmm.
hole and it should be filled. Or, you work with someone like us who's looking at both the fab and the assembly together and trying to give that feedback up front. So
Mm-hmm.
that's our DFA, DFM process.
Now, your opinion. So there is big difference if you are manufacturing or if you are designing a board which is going to be manufactured, let's say, 1,000 pieces a month or million pieces a month. Is it like big difference?
Definitely.
So if someone is designing or doing design for 1 million pieces a month, then design has to be like perfect.
Bulletproof, yeah. I call it bulletproof design.
That's interesting because all the smartphones are like this kind of mass production, and then when you have a look, the technology of the PCB and all the components is like super high density, and they are still able to make this kind of quality designs.
Oh yeah. I don't have any input on cell phone manufacturing or design since that's not my cup of tea. There's probably so many other people more knowledgeable about that. Um, One thing I would say is that when you reach that level of mass production, then the manufacturers have the opportunity to really perfect the manufacturing process for that type of design.
Oh, okay. So it's not only about the design, but again, it's also about tweaking the manufacturing process or assembly process. Mm-hmm.
So, for example, in our facility, because we're high mix, we'll have one design that has heavy copper, and then we'll have another design that's tight pitch. Whereas if I'm a cell phone manufacturer, everything I manufacture is low copper and tight pitch. So there's no variation, it's all the same.
Mm-hmm.
Now, if everything's coming in the same, then I can tweak my manufacturing operations to be the best for that design.
Mm-hmm.
So if you ask a cell phone manufacturer to all of a sudden manufacture power boards, boards with heavy copper, they won't be able to do it, or they'll
Mm-hmm.
do a very bad job. So
Okay,
it's
I understand.
catering to that level of technology. There's no variation, so they can do whatever it takes for that
Oh.
specific product.
Component rotation.
Yeah,
Can we find slide about the
yeah, there's a
rotation
slide for
here?
that.
So this is
But
the
yeah,
most common mistake.
yeah.
What's what kind of mistakes they do, and how the engineers can fix it?
Understand where your pin one is on the component and understand that your marking is there and correct. So
So what do
if
you
you don't,
usually see when you say it's the most common mistake? There is like difference
no,
between component rotation in the pick and place file comparing to footprint, or
exactly. Yeah, that's exactly the issue. Um, if the ones that are easy, of course, are there's no silk screen writing at all to mark pin one,
mm-hmm.
or it's not clear which one is pin one. You know what marking is pin one. Um, but let's say there is a marking, then the DFA will check the rotation in the XY data and say, based on the actual physical component and the rotation and the board, is everything lined up? Is everything correct?
Mm-hmm. So basically, the operator who is setting up the machine, they always uh, check also datasheet of the component, or okay, and they have a look where is pin 1 located, and then they have a look on the PCB or assembly drawing or something, and
Right.
they place the component correctly into machine. Okay, so what kind of documentation is the best for you? I already mentioned assembly drawing. Do you use assembly drawings for this kind of situation?
Yes, I mean, assembly drawings are always nice to have. Um, and then marking it on the drawing, yes, absolutely. Sometimes it's not feasible. Maybe the board is very dense. Um, so yeah, we're then depending upon um, um, our own homework in the DFA process. But I think if you have a layer, an assembly layer, assembly drawing layer in your design, that should be plenty.
Hmm.
Uh,
Is there any other situation where you use assembly drawing layer during assembly process?
oh yeah, all the time. Yeah, assembly drawings are, it's the instructions for our assembly team. Any critical steps or critical process steps, that need to be done. The more you know, the more you can say, the better. If there's a component that is not good for washing, let's say it's a microphone, put that on the assembly drawing. If there's, kind of, pre-tinning that needs to be done of the components, mention that as well. So assembly drawings are critical for any special process steps that are required.
Okay,
If there's no special process steps, then, you know, I guess the basics, right? It's a Rojas board. It's, you need pin one, use no clean flux, you know, like that.
hmm I'm asking all these questions because some people they still don't create assembly drawings, or all your customers they send you assembly drawings. So you have only the.
All of our customers, 90% of the time, will send an assembly drawing. Yeah.
And what kind of information, what else you would like to find there, or what else you need also, like what kind of bombs, bill of materials will help you in what kind of format? Because very often, for example, I generate one component per line, then also I generate grouped components, or this kind of stuff. What is useful?
Um, the basic information is any sensitive components. So, and then what kind of flux to use and what IPC standard to,
Flux. Oh, I never put that information. What kind of flux to use?
um, you know, the more you can specify, you're better off you are. So remember I was talking about the baseline, having a baseline and then deviation from the baseline. Same thing with your drawings. If you put it down in your drawing, now the vendor has to say, I followed your drawing or I didn't follow your
Mm-hmm.
drawing, and this is what I didn't follow.
Mm-hmm.
And so that's serves as the baseline, which is the most important thing. If you don't provide any assembly drawing or just a few points, then you're going to get whatever. It doesn't, you're not going to know what you get.
What kind of other errors mm, are like the most common mistakes?
Then the next would be like the wrong footprints.
I remember this. Yeah.
Yeah, incorrect footprints is a big one
This is some.
because, yeah, go ahead.
This is something what uh, I believe if someone is doing their job properly, that should not happen. Because, for example, very quickly I learned that before I send PCB to production, I should always also buy the physical components and check the footprints. Because if you don't do it, then there is like very very high chance that there is going to be mistake in footprint. And
Yeah,
I think
it's true.
if assembly house will find out that there is a uh, mistake in footprint, that it's actually mistake of the hardware design engineer, it was very irresponsible to send this kind of board to production.
Yeah, I mean, yes, I like what you're saying, but it's not realistic. Designers make mistakes all the time. They make because there's so much to worry about in your, there's so much to worry about. Is it, can one or two things escape? Yeah,
It
you
should
can
it
definitely.
should not. This kind of
It should
mistake should
not.
not happen because this is not
It sh-
really mistake. That's something. It's not like making mistake in semantic circuit because you thought it's going to work this way, but it actually there was something what you didn't consider and it's working differently. That's okay. That's mistake. But like creating wrong
this is
footprint.
carelessness. Yeah, I think you're saying. So I'll give you an example where, you know, so if you designed your board and then the component's not available and then you have to pick a different footprint for the same component, or someone else, the fabricator suggested an alternative component which is a different footprint, you know there are things that will induce the mistake that may not even be the designer's issue. It's like, you know so but yes, right now things change all the time. So, but you're right. It's
It should not happen.
it should not
Especially,
happen.
I learned this. I was very careful about this even when I was working for a company, but especially when I'm paying for everything by myself,
Hmm.
then I'm like, I would be really disappointed if there was this kind of mistake and then you have to pay another $10,000 just because someone didn't buy $1 chip and didn't put it on paper and compare the footprint.
Yeah.
So
Well,
yeah,
so I think customers who do that, that's great. They should do it. But if they don't do it, we'll take care of it.
that's
Well,
good
yeah.
because I remember also, as you said, it doesn't have to be. It can be, for example, that company buys a component in wrong footprint. It has happened, but again, this is something what I learned that I definitely should buy always the components before finishing the board because then I'm sure not only footprint is correct, but also the part number is correct. You really don't want to buy thousand $10 chips and then find out you bought them in wrong footprint. Yeah, no one is going to take it back, or if they take it back, not for the original price.
That's
Okay,
true.
so we can move to a different one. Okay, let's have a look on some other slides. What do you have here? Minimizing assembly errors. So capabilities: board size, spacing, drill holes, solder mask, solder paste. I'm I'm curious. I uh, some time ago someone told me that when doing these stencils, I there is now kind of option to make them some kind of 3D, so you can control thickness of the paste in different places on your PCB.
Yeah, that's possible.
So how do you do that?
It's nothing that innovative. It's just literally a multi-step stencil. So in certain areas, you have a second layer of stencil. So
Oh,
thicker. It's a thicker stencil. And so therefore the solder volume would be thicker in that area.
but how do you make this kind of stencil? So there are like literally two stencils on top of each other. Hmm.
Yep.
Okay, I understand. That's good to know. I didn't. I thought they use laser or something to remove. will be
Most
expensive.
of most manufacturing is very low tech, I would say. The equipment is very expensive, but then the equipment is very focused on what it can do. So, you know, how something is done, it doesn't change very much. It needs to be very repeatable because the equipment that you have only does one thing. And you can't, it's very hard to be able to afford different equipment that do things in a different manner. Because if it's not needed all the time, then is that $500,000 investment in the equipment worth it? The answer is no. So, equipment is very uh, focused on how and what it does, and that's it. Like nothing,
You have to keep
very
using
little
it all the time,
variability.
24 hours, 7.
Yeah, it wants to do the same thing. So a multi-step, so a solder paste machine that somehow can vary the thickness of the solder paste as it's putting it down, stuff like that, that doesn't exist. But,
Mm-hmm.
modifying the tooling or the stencil, will equal different results. So that's
Mm-hmm.
kind of that's the deal. That's the tooling. That's why the tooling step is important in general. Is what can you, the machine's not going to do it, but what can you do to set that machine up for success or what you want? So that's the tooling. I think this is an important part. Maybe everyone knows about this, but
Okay.
placing components too close to the board outline or too close to the edge.
Okay, why is this
Yeah.
important?
Well, so uh, when you assemble, most of the time you assemble in panel form, and then you depanelize after assembly is over or done. And when you're depanelizing, do you have enough space to physically cut the board out without impacting um, the components, without providing any extra stress on the board? Any extra stress could cause a component to, let's say, a solder joint to fracture.
Mm-hmm.
So if you put your components too close to the edge of the board when you're depanelizing, that extra force of depanelization is more dangerous when the component's closer to the edge of the board.
Mm-hmm.
The component is more on the inside of the board, then those extra forces aren't going to play a role in that solder joint.
So if you need to have components close to the edges, then you need to use different kind of techniques. For example, you can mill around the PCB, or how people do it.
Well, the first thing to do is if you're going to have components close to the edge of the board, um, definitely don't have components and the tabs next to each other.
Mm-hmm.
So you have to, as a designer, decide where the tabs are going to be located in your board. And so give your fabricator plenty of space to, not fabricator, your assembly facility, plenty of space to depopulate that board from the array. That's one thing. The second thing is when boards get really tiny, um, don't use a mechanical router bit to depanelize. Don't snap and file. I would say start using a laser depanelization.
Can you do that? I didn't know you can do this, because this is
Yeah.
exactly something what friend of mine, they had like many problems with this, because they manufacture super small computers on module, and the components, they go all around the edges, and the assembly house, they broke so many expensive boards when they were taking them out from panels.
Yep. Yeah, you have to create your process for depanelization for that. So since we do dense boards, we know how to do that, and we use laser.
So by laser you can cut the tabs. Okay, I need to tell him. So tell the assembly house to buy the new machine.
And again, every machine is like so expensive. So do you want to spend $500,000 on a machine to depanelize when you have only one customer that has dense boards like that? So the answer will be no for the manufacturing house.
He can
So
try.
that so
So
it's
they
okay
have
to
new
try.
toy.
Yeah. So, but it doesn't hurt to try. I agree.
Okay, so that's the main reason. Main reason is because I think very often the V cut is used, for example, and that's the kind of way which really will need a lot of space, I guess, from the
It
edges of.
needs space and it provides it, you know, there's extra forces on the board. That's like the worst way to do it.
Okay, what else is here?
So I think that's critical. That's a critical one people often mistake. Here is just spacing. So part to whole wall spacing
So this was
or part to
interesting. When I
end.
was looking at these slides, I had no idea why part to whole spacing. Part, it's like by part you mean component,
Mhm.
like resistor, for example. Eh? It should not be too close to a hole.
So
Why?
that kind of goes back to our wicking discussion. Um, if your solder paste could wick into a hole that's too
Mm-hmm.
close. Um, I think that's the main thing. And then, for a PCB manufacturer, to ship a good product, it's called drill to copper, right? But the part can possibly, um, let's say, overhang. Um, is that bad? Probably not.
Mm.
So yeah, I would say drill to copper is important for a fab house, and it's important for the assembly facility as well. The critical dimension there is the solder mask web. So, that should actually be added to this discussion because a lot
Solder
of
mask.
fabricators, solder mask web, a lot of fabricators will remove the solder mask web. So meaning if there's solder mask in between a hole or a pad and a component, but the solder mask thickness is too thin, meaning if the width is too thin for it to properly adhere to the board, then the PCB fabricator will remove the solder mask web.
So we are talking about the slivers between the parts, for
Yeah,
example. Okay,
yeah, yeah.
and so they draw like rectangle around all the parts, for example. And
Yeah, they create
how bad is it then for the solder bridges? Is it like much worse than
much
if
worse. Yeah.
so the solder mask is really helping to prevent creating these solder bridges?
Yep.
Okay, and but sometimes this is difficult because sometimes the paths are very close to each other. So does it
Yep.
mean designer should always try to keep the solder mask even in cost of making the opening almost size of the path?
Absolutely. Yes.
Okay. And what is the minimum opening around the path? Do you know the standard minimum opening? I think you can use like 0.075 millimeter. I don't know. It's like three mils.
That would be a lot. Yeah. That would be, I was going to say like a third of that.
1 mil.
Hmm.
Okay.
But yeah, more the better.
Okay. So you can make a small opening around the pad as 1 mil, and it's still
Mhm.
PCB house still can manufacture it with no problems.
Mhm.
Perfect. Okay, so what is on the next
And
slide?
the web should be the actual solder mask width should be 4 mils.
Four
That's our
mils.
rule.
Mm-hmm.
Yeah.
So that's like zero
So
point 0.1 millimeter.
yeah,
Mm-hmm.
if the solder mask width needs to be thinner, it can be, but it requires much more attention to detail in manufacturing of the PCB.
Mm-hmm. Oh,
But yeah,
and what about the exposed pads? I think I haven't seen anything about exposed pad here. But what is your recommendation to mm, make good footprint for exposed pads? Like because ideally you would like to make their small squares for the solder, for example, or how does it work? What do you think is the best?
can
So
you
when you have
rephrase?
exposed pad under the chip, then it's not the best idea just leave one big pad and put their solder on whole big pad. Ideally you would like to split it into number of smaller squares, for example.
Yeah,
So
that's stencil designed by the fabricator.
mm-hmm.
That's up to the customer. I'm sorry, that's up to the vendor to decide what's the right way to put down the solder paste to get the right volume.
Oh, that's interesting. So even if you don't do it, or if the designer doesn't do it, then you will do it based on your experience.
That's right.
Okay, I didn't know that.
Yeah, that's a critical step in the assembly manufacturing to get stencil design correct. Um, if your stencil design rules are not good, then you'll have lots of solder defects. So that's like number one. That's the number one thing.
So you never use the mm, stencil design which is delivered from designer. You do it based on pads, for example. I didn't know that.
Because if we followed what the customer gives us, it'll always be wrong.
Really? I should
So,
start asking what kind of changes the PCB house and assembly house always do. Then I could make more YouTube videos. Okay, what else do we have here?
um, I think that was actually like the big common issues. I think that you know it doesn't sound like a lot, but it is a lot. Meaning, because every design is unique, how these things come together for your specific design really determines the success you're going to have, success or failure. So, for example, let's say that, well, no, I won't go there, but basically, you could have so many different root causes of your defects, even if you do everything perfect. So, it really comes back down to the design itself and what kind of investigation you do into the root causes of the issues that you do experience. So that's to me that's the most important thing. Everything else can be uh,
I'm listening. I'm listening. I'm just making notes.
sure. So I guess for example, I'm trying to think of a good example, but it's hard to. So basically, when you assemble a product, there will be defects. When you manufacture a circuit board, there are defects, but you don't see the defects. If your fabricator is good, they don't ship you the bad boards, right? For an assembled product, you do get defects, and it's up to the fabricator to the assembler to fix the defects prior to shipment, but every solder joint is a potential for a defect, and the customer can see every solder joint, and there's no way to hide a defect, right? So if you're owed 10 boards in your assembly process from your assembly order and you get 9, well, it's very obvious, right? And there's no overage per se. There's no concept of overage in assembly, but there is a concept of overage in PCB fabrication. If you are owed 10 boards, the fabricator may make 12 and decide these 2 are not as good as the rest, so I'm going to ship these 10. In assembly, it's much more difficult to have a concept of overage. So now yield is much more visible and defects are much more visible. So the question is, did you do a good design job to eliminate variation? Number 2, what are the defects and the root causes? So it becomes a much more important exercise to go over the root cause, because there's always mistakes. If you don't go over the root causes, then you would just keep making the same mistake.
So you have this kind of document which can help people?
For what specifically?
With creating better designs to prevent all the kind of assembly problems?
Yeah, we do. So we have a DFA handbook. It does go over some root cause examples, and it does give some guidelines on how to, prevent those from happening.
Okay, so people can download it if they want. Okay. I've seen thermal relief somewhere here, so I made a note. When I was starting with hardware design, I didn't know it's important until from assembly house they called me and they told me they can't solder some of the ground pins because they don't have enough powerful soldering irons for these 4 grounds which are connected to these pins.
That's true.
So that's the problem. Mostly for through hole pins connected to multiple ground planes, which are very hard to solder.
Absolutely true. Yeah, absolutely true.
Are there any other situations when thermal relief can be useful?
I think thermal relief, from a manufacturing perspective, you just have to design it properly, and so that's what figure B is showing. That this is how one way to design properly. And then you have other options as well. How you want to design your thermal relief, but you don't want to cause slivers. So you have to be aware of where the copper is and where the copper isn't, right? Because where the copper isn't is also important in manufacturing. And, so from a manufacturing perspective, I would say these are the key points, and how to properly design your thermal pads. From an electrical standpoint or manufacturing standpoint, I think you covered it.
Okay. I would like to ask, again, many people ask me, when the board has components from both sides, how is it assembled? Like, because we already know that you need to put paste, then you need to put the components on one side, and then what do you do? Do you send it to oven, or you just flip the board, put the paste and components on the other side, and then you send it to oven, or how is it done?
So when you're saying, so what's the process for double-sided assembly? Is that
Exactly.
what you're asking? So it really depends on the BOM, the bill of material, and the components that you're using as to what process flow is done. But let me see if I have the process flow here in this document.
Oh, so there are more options. For example, if you have just small components from bottom, then you can fit both sides and then send it to oven all at once. But
Exactly.
if there are like heavy components, chips on both sides, then you may need to do it twice.
Exactly.
Oh, I didn't know that. So what can be the factors? Because this can be something what can help engineers again to design maybe more cost-effective boards for assembly.
Yeah.
Because I guess you probably charge more if you do it twice, or it's same price, or
If you have one-sided assembly versus two-sided assembly, that's where we charge.
mm-hmm.
How we build it is we don't,
Oh,
that's
okay.
not where the charge comes
Mm-hmm.
in.
Okay.
So if we can optimize the manufacturing, we will, but that's not a benefit to the customer. That's just what we're doing internally.
Mm-hmm. Okay.
So if you have components on both sides, you're going to get charged for components on both sides.
But still, for
But I think,
example, if it goes
yeah,
to the oven twice, it may be a little bit worse than if it goes there only once, or?
yeah, I think you actually, I'd like to follow up on that, on this point that you're making and talk to our process engineers and ask them, is there any, are you, sorry, Robert, I'm having internet problems.
I still can hear you, okay?
Oh, you can? Okay,
Yeah.
okay. Okay, I lost you. Yeah, so I would like to follow up with our process engineers actually and ask them if there's any benefit or that we can, yeah, benefit that we can extend back to the customer through process optimization. So meaning if the customer did this, would that equal less process in our end? And therefore we can charge the customer less. I think that's a great question. And I'll come back to you with a better answer.
And that's everything for this video. I would like to say thank you very much to Amit for finding time to help me to create this video. Thank you, Amit. And if you have any questions about board assembly or anything what you would like to add to this topic, leave your comments under this video. If you like this video, don't forget press like button. If you would like to see my future videos, don't forget to subscribe. It helps a lot. I would like to thank you very much for watching and see you next time. Bye.